Hey there, 6th grade. In this video, we'll keep on talking about similar figures, and specifically, we'll talk about how you can find missing side lengths of similar figures using proportions. So think about how we can measure the heights of really tall objects. For the example, skyscrapers. If you were asked to find the height of a really tall building, well, one way that would be really difficult is by just taking a ruler or a yardstick and measuring that building. That's because most skyscrapers are going to be way too tall for the use of a ruler or a yardstick or a tape measure. And so instead, one method we have is by measuring a smaller object that is similar to the object that we want to measure, and then using proportions to find the missing length. And so that's what we're going to do in this video here. And when we do that, that's actually called indirect measurement. So anytime you see that phrase indirect measurement, it's a method of using proportions to find an unknown length or distance in similar figures. So in example 1, you have two triangles, and I'm telling you in the directions that these triangles are similar. And you're being asked to identify the unknown side length, and that unknown side length we're using an x to represent. So you're being asked to find what the length of this side here from L to K is. So in order to find that missing side length, you first of all need to identify what is the corresponding side to this side LK in the smaller triangle. Well, notice that these triangles aren't in the same position, and so we need to rotate one of our triangles so that they look similar to each other. And so what I can do is I can redraw my larger triangle so that what appears to be the shorter side, this 28 centimeters, is here on the left, and then my larger side, or what appears to be my larger side, that has the X is on the right. And now it has the same sort of direction that this smaller triangle has. Okay, so I've rotated this now, or flipped it, so that J, point J is here, point L is here, K is still on top, and now X is this side, 28 is this side, 56 is still the bottom. So now it's pretty easy to see that this side from K to L is corresponding to this side from B to C. And so I can write a ratio comparing the side BC to the side KL because they're corresponding sides. I can do the same thing with another pair of corresponding sides. I can identify that side AB corresponds to side JK, and so I can write a ratio comparing those two sides, AB to JK. The key to this whole problem is the fact that these are similar figures, and because these are similar figures, we know that the ratio of the side lengths of corresponding sides are proportional, and so therefore I can make this a proportion. I can set these two ratios equal to each other. So now what I'm going to do is I know 3 of these 4 side lengths. I know that side BC measures 12 centimeters, so I'm going to replace the BC there with a 12. I don't know side KL, that's that variable x that I'm using, so I'm going to put an x there. And then I know my other 2 side lengths. I know side AB is equal to 8 centimeters, and I know side JK measures 28 centimeters. So now I have a proportion, 12 over x equals 8 over 28, and I can solve that proportion using my cross products. So 28 times 12, be sure to show your work for that multiplication. 28 times 12 is equal to 336. And then my other diagonal, we have x times 8, or 8x. So we have 336 equals 8x. And now when I divide both sides by 8, 336 divided by 8 gives me 42. Okay, so we can say that the missing side, KL, is 42 centimeters. You'll notice that I chose to use these two sides in my proportion AB and JK, but I could just have easily used the sides AC and JL, 16 and 56 here, and I would have still gotten the same answer. So it really doesn't matter which corresponding sides you put in your proportion, as long as the sides that you pick are in fact corresponding to each other. Okay, let's try this now for number 2. This one says that a volleyball court is a rectangle that is similar in shape to an Olympic-sized pool, and our job is to find the width of the pool. So let's identify our corresponding sides. Okay, I have the shorter side of my smaller rectangle, this volleyball court, which is 9 meters, and I have the shorter side of the swimming pool, which is the side that we don't know, so we're going to put a variable there. We can use an x again for that. And then we have the length of the volleyball court, which is 18 meters, and then the length of the pool, which is 50 meters. So I can write a proportion. I can compare my shorter sides, that would be 9 meters compared with x meters, 9 to x, and then I can write a ratio on the other side that compares my 18 to my 50, and set these two ratios equal to each other. So now, using my cross products, I can take 9 times 50. That gives me 450. And then 18 times x, which is 18x. I can then divide both sides by 18 and go ahead and pause the video and work that out over here on your own. When you divide 450 by 18, you get 25. So our missing side length there is 25. And so that means that the pool is 25 meters wide. Okay, one more example. We have a birdhouse in Chantel's yard, and it casts a shadow that is 13.5 feet long. And Chantel herself, here she is, casts a shadow that is 3.75 feet long. And the question asks, what is the height of the birdhouse? Well, if you notice, the heights of both Chantel herself and the birdhouse, when you put those together with the shadow lengths, you form triangles, specifically right triangles. So this is another similar figures problem, and we can use the shadow lengths down here and the height of Chantel to find the height of the birdhouse, once we recognize that these are similar triangles. So I'm going to write a ratio that compares Chantel's height, which is 5 feet, to our missing height, which is the height of the birdhouse, and that's going to be h. And then on the other side of my proportion, I'm going to compare Chantel's shadow length, 3.75, to the shadow length of the birdhouse, which is 13.5. So I set these ratios equal to each other. And now again, I'll use cross products to find my letter H. So 5 times 13.5. This is why we practice working with decimals at the beginning of the year. We get 67.5 when we do that multiplication. And then that's equal to 3.75 times H. So we will find H by dividing both sides of this equation by 3.75. I want you to pause the video now, do this decimal division, and then once you have your answer, click play to check. Okay, if you did this correctly, you should have found that 3.75 goes into 67.5 18 times. And so we can say that the birdhouse is 18 feet tall. Okay, if you had any questions over this video, 6th grade, make sure you have those written down for the next time you're in class. Until then, have a nice day. You're all wonderful people. Take care.